Hi folks, we're going to learn how to do a new type of reaction here where we're going to balance these reactions, and these are a little bit more complicated than some of the other things that you've seen before. I'm also going to point out to you that these reactions are not going to fit into our big five, so double replacement, anything like that. So don't try to fit them into those. On these reactions, what you're going to have is you're going to have something that's going to be a redox reaction, so oxidation reduction occurring, and it's going to happen either in an acidic solution or a basic solution. And I've got examples of both types here. So the first thing to note is you're never going to need to say, do I think this is in an acidic or a basic solution? There should always be some sort of clue given to you about if this is happening in an acidic or a basic solution. And these steps are going to tell us how we're going to do the balancing. And I'm going to get to these in a moment here. When you see these types of reactions, they should look a little bit funny to you. And what's going to be the thing that's funny about them is they're not full and complete reactions that you're looking at. I'm seeing in 3 of the 4 situations of this particular thing, of this kind of a skeleton reaction, I'm seeing some ions. You cannot have ions existing under normal circumstances unless they are aqueous. You can also have gas phase ions, but this just isn't going to be that type of stuff. So as soon as you see ions, you should be thinking aqueous to yourself, and we're going to have to balance these. But we don't have all the parts yet in these reactions in order to balance them. Sometimes you're going to see things like, let's look at this reaction for a second. This must be an incomplete reaction. And the reason why I'm saying that is, look over here. This is dichromate. It's got some oxygens in it. Look over here, and there is no oxygen. Eventually, we would have to balance that, but clearly there must be some other species that needs to occur over there in order to be able to balance those oxygens. So these steps are going to tell us how to approach these things. And while these are going to look like they're very complicated reactions, these steps are super systematic. And so you will need to be able to do this on your own without the steps, but you're going to find once you practice a few of these, they're going to have a rhythm to them that's going to be pretty easy to follow. Okay. So first step, so we're going to do this problem right here. First step, assume this process takes place in an acidic solution. This can be altered for basic solutions at the very end. So I don't care if it's acidic or basic, you're going to assume that it's acidic. And then you'll see step 6 down here is where we would go back and change things if we needed to, if it was actually in a basic. So always assume acidic solution. Write 2 incomplete half reactions, one for oxidation, one for reduction. Okay. In order to do this, it's really important to have the skill for understanding oxidation numbers and what is an oxidation half reaction and reduction. So the first thing we're going to do is we're going to assign the oxidation numbers to all of these things. So hopefully we've been practicing this a little bit. This one looks really easy to me. This has to be a +2. It's the only thing that's sitting there. And the oxidation number has to match the charge of the compound or the polyatomic when you add the oxidations together. Okay. I'm going to come over here and do this one next. Always assign a -2 to oxygens to start with here. There's some exceptions, but let's not deal with that right now. And remember, my total needs to add to a -2 because that's the polyatomic. So I'm going to have a -2 for the oxygen. There's 4 of them, so that's up to a -8. I need to have -2 left over. There's got to be a +6 between these 2 carbons. And so each of these is going to be a +3. All right, let's go do this one next. Again, -2 for my oxygens that are in a compound. So again, I have 4 of them, so there's -8 there. I'm going to have a negative left over, so this must be a +7. That has to be held entirely in that manganese. And then the last thing over here is my carbon monoxide. Oh, I'm catching this right now. There's a typo on there. You should adjust your sheet accordingly. This is supposed to be carbon dioxide. This just wasn't looking correct here. So this is going to be a -2 for the oxygens, and then this is going to be a +4 for that carbon there. So again, that only is going to work out with the 2 for carbon dioxide there. All right, now that I have this, what I'm going to do is I'm going to look for what is oxidized and what is reduced. And so the thing that is oxidized, it doesn't really matter which order I'm doing this in, so I'm just starting with oxidation. The thing that's oxidized, so Leo the lion, losing electrons is oxidation. All right, so what lost some electrons in this process here? So let's look at manganese first. Manganese is a +7, and then it goes to a +2. This actually gained electrons. So this manganese is going to be my reduction. So the oxidation must be the carbon here. So carbon went from a +3 to a +4. So each of these carbons lost an electron. So my oxidation step, I'm gonna write out the full compound here. I would coach you. You're gonna put a lot of extra stuff on these reactions. I would coach you to build out from the center so that you always have room to add things on either side. Okay, so I'm gonna write C2O4 2- is gonna go to, and then I need the other thing that has the carbon in it. So carbon dioxide. And like I said, I'm gonna start in the middle and I'm gonna build outwards. That's just for room on the page. Okay, so in oxidation, what we're going to have is we're going to have electrons that are going to be free. So if you lose electrons, this thing had them, and this thing is going to lose them. So I'm going to put plus an electron over here. All right, so this is the start of my half reaction. But this is not a full and complete half reaction, so let's do the reduction half reaction now. So again, I'm going to build out here. I already figured out that manganese was the thing, so I'm going to write NNO4-, and this is going to go to NN2+. Okay, GR for Leo the lion, or oil rig, whatever your preference. Reduction is gaining electrons. So this thing is going to have more electrons on it, and they had to come from somewhere. And so I'm going to put in electrons that were hanging out over here somewhere, and those things are going to get captured in this manganese here, and they're now kind of embedded within this thing. All right, so now we need to balance our reactions here. So this is 2 incomplete half reactions. All right. So balance each half reaction. Balance atoms other than oxygen or hydrogen first. Okay, so first I need to balance carbons here. All right, so I see 2 carbons here, only have 1 there, so I'm going to put a 2 in front. So now I've balanced my carbons. Okay, the rest is oxygen. Okay, balance oxygens by adding water molecules. All right, so I have 4 oxygens over here, and I have 2 times. So look at this, I also have 4 over here, so those are balanced. Balance hydrogens by adding H pluses where necessary. I have 0 hydrogens and 0 hydrogens, all right? Balance charge by adding electrons. This is really important. It says you are not seeking to make each side of the reaction neutral. You are just trying to have the same charge. All right, so I have a -2 right now over on the left-hand side. And these electrons are going to allow me to change the charge of things here. So I have a -2. If I had some other coefficient out here, I'd be taking that into account. I only have a 1 though. So -2, this is neutral. I'm going to need 2 electrons over here. All right. So let's stop there. Let's go balance this one. Okay, balance anything that's not oxygen or hydrogen. Manganese, I have 1 of each, so those look good. Balance oxygens by adding water molecules. Okay, I've got 4 oxygens over here, 0 over here. I'm going to need to add 4 water molecules. All right, now what I have done is I've taken my hydrogen out of balance. Balance hydrogens by adding H pluses where needed. Okay, so I have 8 hydrogens over here. I'm going to come over here and I'm going to add 8 H pluses. I still have to work with this guy here. Balance charge by adding electrons. We are not seeking neutrality. All right, so I'm adding my electrons over here. That makes sense with reduction. Let's go see what I'm at over here for my charge. So I'm at a +2 on this side. I need to make this side also a +2. All right. So if you follow here, I have a +8 to start with. There's a -1 here, so now I'm at +7. If I have 5 electrons, so we're just doing the arithmetic here. But so here's +8 -5. Now I'm at +3 minus another 1. I'm at a +2. So I'm at +2 here, and I'm at +2 here. Okay? So I have balanced charge on both sides. Balanced charge. Okay, sorry. Now what we need to do is we are going to cancel the electrons on the left and the right after we add these. So what I need is I need the number of electrons to match in both of these half reactions. And I have to do some multiplying through both reactions in order to achieve that. So it's kind of like a cross-multiplying idea. If I do times 5 to this reaction, this is going to be at 10 electrons on the right. And if I do a times 2 down on this one, now I'm going to have 10 electrons on the left, and those are going to cancel. Okay? So we're going to add the reactions, and we're going to cancel excess substances on both sides of the half reactions. Okay, so you just got to be really careful when you're doing this. I need to distribute the 5 into everything. I need to distribute the 2 into everything here. All right, so I'm going to go 16 H pluses plus 10 electrons plus 2 manganese with that. Okay, and then I still need this guy. Plus, this time it's a 5 coming in. 5. C2O4, 2 minus. Goes 2. All right, this is no particular order, right? So now I'm doing 10 carbon dioxides plus 10 E minus plus 2 Mn2 plus 8 H2O. Okay? So again, just be really slow as you're doing that. Okay, what can I cancel? I can get rid of these electrons and those electrons. That's it. That's all I can cancel right now. Okay, so this is the final answer except minus these electrons right here. And again, it doesn't matter what order you put it in. So I have balanced this reaction in an acid. And let's call it good for there. I'm going to make a separate video for the basic solution because these can be a little long here. All right, hopefully that helped.